On the first night of July 2025, a telescope in the Chilean desert was doing the most boring job in astronomy. Photograph the sky. Compare it to last night. Look for anything that moved. Most nights, nothing does. That night, something did. A faint smudge of light, out past the orbit of Jupiter, sliding across the star field far too fast. The software flagged it, the way it flags 1,000 asteroids a year. Then someone looked at the speed, and the speed did not make sense. Whatever this was, it was not falling around the sun. It was falling through the solar system on a path that would never bend into an orbit. It would arrive once and keep going. It had come from somewhere else. And in the months that followed, the more carefully we looked at it, the stranger it got. They named it 3EI Atlas, the atlas for the survey that caught it. The 3I because it was only the third interstellar object we had ever seen. The first was Oumuamua in 2017, a sliver of something that tumbled past and was gone before anyone could agree on what it had been. The second was a comet called Borisov in 2019. This was the third, but this one was different from the moment it appeared. It was bigger, brighter, and caught much earlier, while it was still far away and inbound. For the first time, we had an object from another star coming toward us, with months of warning, and every great telescope on and above the Earth was free to turn and stare. Here is the part that tells you it was a true outsider. When Atlas found it, it was moving at about 137,000 miles an hour. As the sun's gravity took hold and reeled it inward, it sped up, the way anything would, until at its closest it was tearing along at 153,000 miles an hour. No object born in our solar system moves like that. That velocity is a fingerprint. It means this thing was never ours. It was passing through on loan from the galaxy for a few short months, and its trajectory traced back not to the familiar disk of stars around us, but to the thick disk of the Milky Way, an older, deeper population of stars most of us never think about, which raises the first thing that genuinely unsettles the scientists who study it: its age. A team led by an astronomer at Oxford ran the numbers on where it came from and how stars in that part of the galaxy tend to be dated. Their answer, with reasonable confidence, was somewhere between 7 and 14 billion years old. Sit with that for a second. Our sun is 4.5 billion years old. The Earth, the same. This object was very likely drifting through interstellar space for billions of years before our solar system existed at all. There was no sun, no Earth, no life, just a dark, frozen traveler already ancient, already on its way, while the cloud of gas that would one day become us had not yet begun to collapse. It may be the oldest comet human beings have ever laid eyes on. So we pointed the James Webb Space Telescope at it and read its light. And that is where the dossier really begins, because when you break apart the glow of a normal comet, you find what you expect. Mostly water ice, boiling off into a bright halo as it nears the sun. 3I Atlas was not normal. Its coma, the cloud of gas around it, came back as roughly 87% carbon dioxide, 9% carbon monoxide, and only about 4% water. That is not a small deviation. That is the recipe of a comet turned almost completely inside out. It holds one of the highest ratios of carbon dioxide to water ever measured in any comet, anywhere. Whatever star system cooked this thing, it cooked it under rules that were not our rules. Then it got worse, in the specific way that makes a scientist go quiet. The instruments found nickel, metal, in the gas around the comet. On its own, nickel in a comet is not shocking. But this nickel showed up at a temperature of around 150 Kelvin. That is far, far too cold to be boiling metal off of rock. Nickel does not turn to vapor at those temperatures. It should not have been there at all. The chemistry that best explains it involves a compound called nickel carbonyl, a delicate molecule of nickel bound to carbon monoxide. And here is the detail people keep repeating, because it is hard not to. On Earth, that exact reaction is something we engineer on purpose, in factories, to refine pure nickel. There was nickel coming off this object in a cold, almost industrial-looking process, and it arrived strangely alone, without the iron that almost always travels with it. And then there was the tail. Comets have tails. We all know what they look like. The solar wind blows the gas and dust away from the sun, so the tail streams out behind, always pointing away from the heat, like hair in a current. 3i Atlas grew a tail that pointed the wrong way. For a stretch of its approach, it showed a jet reaching toward the sun, into the wind, against everything the textbook says a tail should do. When two researchers processed the images more carefully, they found something even harder to picture. Not one jet, but a set of them. A main spike aimed at the sun, and three smaller jets spaced almost evenly around the object, about 120 degrees apart, sweeping around as the whole thing rotated once every 7 hours or so. A cold, ancient rock turning slowly, firing in a strange symmetry. All of that venting has a consequence. When a comet sprays gas in one direction, it gets a tiny nudge in the other, like the world's gentlest rocket. And near its closest approach to the sun, the measurements picked up exactly that. A small extra push that gravity alone could not account for. The amount was minuscule, a whisper of acceleration, but it was real, and it was there, and it had a direction. For most comets, that is the end of the story. The ice vents, the comet drifts a hair off course. Nobody loses sleep. For this object, with its inside-out chemistry, and its impossible cold metal, and its symmetric jets, that little push landed differently. It became one more line in a growing list of things that were not technically supposed to happen. There is one scientist whose name is attached to almost every uncomfortable question about this object. Avi Loeb, an astrophysicist at Harvard, the same man who argued years ago that Oumuamua deserved to be taken seriously as something other than a rock. With 3i Atlas, he did the careful work on those jets and that acceleration, and then he asked the question out loud that the symmetric pattern seemed to invite. Were these jets simply pockets of ice that happened to sit in a neat arrangement on the surface, or were they something that had been placed? He stopped short of an answer. He has always stopped short of an answer. But he kept the question open, on the record, while the object was still close enough to study. And that is the line the whole field has been walking. How do you stay honest about an anomaly without pretending you already know what it means? So let us be honest the other way too, because the most likely explanation for all of this is not a spacecraft. It is a comet. A very strange, very old comet, but a comet. The cold nickel, the carbon dioxide, the reddish organic stained surface, every one of those can be read as a chemical postcard from a star system unlike ours, formed under a different sun, frozen for longer than the Earth has existed. When the Hubble Space Telescope finally pinned down its size, the solid nucleus came out to about 2.5 kilometers across, an ordinary size for a comet. And as it rounded the sun and began to leave, its activity faded along a curve that, for all the drama, looked perfectly normal for a natural object. By the numbers, It behaved like a comet. The exotic parts are exactly what you would expect from the one thing it truly is. A messenger from a place we will never visit. Which brings us to the part that should actually keep you up. Not aliens. Time. Because 3i Atlas is already gone. It came in fast, swung inside the orbit of Mars at the end of October 2025, and slingshotted back out toward the dark. It is not coming back. Not in 1,000 years, not in 1,000,000, not ever. We had a single narrow window to study a 7-billion-year-old object older than the Sun, and we will spend the rest of our lives arguing about what we saw in it, because we cannot go back for a second look. And here is the quiet truth underneath the whole story. The first one, Oumuamua, we caught on the way out, almost too late. This one we caught early, and we still ran out of time. There will be more. New telescopes are coming online now that are built to find exactly these objects. And the estimates say the next interstellar visitor could be only a year or two away. The galaxy, it turns out, has been sending things through our neighborhood the whole time. We only just built the eyes to notice. The unsettling question